Hi everyone, this is Mrs. Van Horn. This is the video recording that's going to help you complete homework A of week 4 distance learning. It's on distance formula. To begin, I am going to go over the document. So you have 3 pages, and the first page I am going to start demonstrating, and then you're going to complete the rest of the problem. The second page you're going to complete yourself too. Okay? And then final page you'll find is the answer sheet. Why do you have the answer sheet? Well, the answer sheets are there so that you can check your answers when you have completed all the problems. You're supposed to use a red pen to mark off if your answers are correct or not. Now, if you just write the answers on your problem as part of your homework, you will get no credit for it whatsoever. You need to show your work that goes with the answer that you got. Also, because I am grading for completion and effort, that means if you get any of the problems wrong, that's fine, as long as you try to rework it and see if you can figure out what did you do wrong. Okay, that is part of math because we really want to make sure you're solving the problems correctly, not just going through the motion and say that I've done the homework. So let's begin. I am going to demonstrate the first problem for you. It says, find the distance between each pair of points using the Pythagorean theorem. Round your answer to the nearest tenth if needed. So you have, let's call this point 1 and let's call this point 2. We're looking for how long is this length. And you are given these 2 corner planes. So what do? How can we find the distance? Well, I hope you recognize that this is a right angle triangle. By definition, because the corner plane, you have x and y axes that are perpendicular to each other, this is a right angle triangle. Now, if we have a right angle triangle and we know the height of the triangle to be certain length and the base of the triangle to be another length, can we figure out the hypotenuse of this right angle triangle? What do we use? I hope you are telling me Pythagorean theorem. So what is Pythagorean theorem? That says a squared plus b squared is equal to c squared, where a squared, a is one of the side lengths, that's called the base, the a, and b is the other leg of the right angle triangle, so this could be called b, and then c is always the hypotenuse, which happens to be what we are looking for. So we know A, how long is this base? 1, count 2, 3, 4, 5. I count 5 units, 5 squares, so I'm going to write 5 here. How long is the height? 1, 2, 3 height squares, so the B is 3. Now can we figure out what the distance is? Well, let's plug that in. A is 5 squared plus B is 3 squared. And instead of writing C, I am going to write D because that's what I'm going to call that distance that we're looking for. That's going to be D squared. So from here, I can simplify this. 5 squared. What is 5 squared? Is that 5 times 2? No, this is 5 multiplied to itself 2 times. So it's 5 times 5 is 25. What's 3 squared? 3 times 3 is 9, is equal to D squared. Now, 25 plus 9 is 34. So, next line, I am going to write D squared first is equal to 34. I'm bringing the variable to the front because it's always nice to have some variable is equal to. So, then what do we do next? We need to take the square root of both sides to get rid of this square. Then this becomes D is equal to square root of 34. Okay? Now it says to round your answer to the nearest tenth. That means use the calculator to find the value. So if I bring my calculator here, each calculator is going to be a little bit different. And so if you're using your phone calculator, that's going to be different also. So I'm going to turn it on, and if I put 34 first, and then I find my square root sign right here. And this is the first function, this is the second function, this is the second function. So I'm going to put second and that. Then you can see that I have the square root sign outside of this number here. That's not what I want. So that means I need to put in the function first. So I'm going to put second square root. Oops. Okay, that didn't clear. Okay, second square root. Still don't want that. Okay, second square root of 34 is equal to, oops, that's not what I want. Okay, minor technical difficulties, but we're back on track now. Okay, let's try that again. So I need to do second square root, and that's going to give me, now that number 34 is inside the square root sign, and then enter, and I get 5.830595, so on. So let me just write that first. And it continues. Now it says to round to the nearest 10th digit. Okay, that means this is the 1st digit, this is the 10th digit, this is the 100th digit, and 1000th digit. That means we wanted to this digit. So we want to cut off here. Now we need to be looking at the number before, next to where we're cutting off. Okay, so number after the where we're cutting off is 3 here. We need to be checking to see, do I round up or do I leave it as it is? If this number is 5 or greater, 5, 6, 7, 8, 9, then you need to round up. And this number becomes 9. However, this number is 3 right now. So 3 is less than 5. So that means I just need to cut it off here. And I don't do anything to it. So distance is 5.8. Okay, so that's my answer. Now, when you have your answer, you should be checking to see, is my answer reasonable? Okay, look at your answer. This length is 3, and if this length is 5, I have 5.8. Now, remember, hypotenuse is always supposed to be the longest side. Is that bigger than the longest side of any of the legs? Yeah, the longest side is 5, and this is bigger than 5. Okay, if this is 5, does that look about right? Yeah, if I was to draw a circle, that looks like about the 5 and a little bit more. So this answer is reasonable. So I know that I think I've got it correct. Okay. However, if you got answers like 0.2 or a big number like 25.7 or something like that, then you know that this answer is probably not right. And maybe I better check again to make sure that I did not do anything wrong. Okay, so that's number 1. So I am going to do number 4 now, because you can do number 2 and 3 yourself. And number 4 is very, very similar, but this time it's asking you to find the exact radical answer instead of rounding to the 1 decimal place. So here we go again. Okay, to tackle number 4, it's exactly the same process. If I am looking for this distance called D, I need to figure out the triangle. I'm going to draw my triangle right here. This is my right angle triangle, so I can use my Pythagorean theorem, which says that one of the leg is, let's count, 1, 2, 3, 4, 5, 6. So A is 6, so 6 squared, plus the other leg is 1, 2, 3, 4, 5, 6. 6 squared is the hypotenuse. Remember, hypotenuse is always the length that is opposite the right angle side. Okay, so that is D squared. What's 6 squared? 36. What's 6 squared again? 36 is equal to D squared. I'm going to bring the D squared first. Is equal to 36 plus 36 is 72. So from here, to find D, I need to undo squaring. So take a square root of both sides. That leaves me with D is square root of 72. Okay, but now it says to exact radical answer. Sometimes this is all we can do. However, sometimes we can simplify the radicals. Okay, so to do that, we need to be looking for perfect squares. Okay, now what is a perfect square? Perfect squares are numbers like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, so on. Okay, what is 1 squared? 1 times 1 is 1. What's 2 squared? 2 times 2 is 4. What's 3 squared? 3 times 3 is 9. What's 4 squared is 16. 5 squared is 25. 6 squared is 36. And 49, and so on. Those are my perfect squares. So now I need to see, okay, can I factor this? Can I make this into a multiple of some of these numbers? Is 72 one of these numbers times some integer? Okay, so and it so happens 72 is actually 36 times 2. If you saw that, that makes it really easy. But if you didn't see that, and if you just saw that, I think it's divisible by 4. So then let's just go with that. I can say this is really same as 4 times 18 is 72. So that means this is same as square root of 4 times square root of 18. Now, square root of 18. Can I go simplify this even further? Okay, is 18 a multiple of one of these numbers? Yes, it's 9. 9 times 2 is 18. So I can rewrite this as square root of 4 times square root of 9 times square root of 2, because 2 times 9 is 18. Okay, now this time let's process the square root sign. Okay, what is square root of 4? That's 2. So I don't write the square root sign anymore because I've taken care of that. Now I've actually evaluated this. So 2 without the square root sign. What's square root of 9? That's 3. And there is a multiply sign there. And what's square root of 2? Can I simplify that any further? No. So that means it's left as it is. Okay, so which then becomes, what's 2 times 3? That's 6. And 6 root 2 is my answer. Okay. All right, so at this point, I would like you to pause the video and do number 2, 3, and 5, 6. And I am going to come back and talk about distance formula. When you're done with the problems, please turn to the next video recording because I am going to show you the distance formula and how to tackle that.